Welcome. So in this lab, we are going to talk about EtherChannel. So I'm starting off with a topology from the previous lab where we have configured VLANs, trunking, routed ports, routing, all of this in this switch block. So we have complete reachability from any device to any other device in this switch block. Excuse me. So EtherChannel. EtherChannel is a port link aggregation technology or protocol, which allows the bundling, the combination of several physical links to form a single logical link between two networking devices. We can see that right here. This can be done between two layer 2 switches, two layer 3 switches over a routed port, or two layer 3 routers. So EtherChannel allows us to enhance the bandwidth by combining these multiple links, capabilities, and providing redundancy for higher network resilience. Again, also providing that kind of redundancy. If one link goes down, we have another link. EtherChannel can operate at both layer 2 and layer 3, and we'll be doing both. So there's two negotiation protocols, LACP, Link Aggregation Control Protocol, which is a IEEE 802.3 AD standard. And there's also Port Aggregation Protocol, which is a Cisco proprietary protocol, both very similar. There's also a method in which you can use static persistence, where you just statically configure it, and there is no negotiation. We're going to be using LACP, and it really is best practice to use one of the negotiation protocols. And I get into that in my lab. I talk a little bit more about that in the lab document. That's available either in the link in the comments or through my GitHub repository. I'll put that link in there as well. All right, so let's get started with layer 2 EtherChannel. So let me go here, look at this switch here. We're going to do our first layer 2 EtherChannel between these two switches here. If I do show running config, okay, and I'm just going to take a look here at FA01 and FA02, and we can see we have a trunk link between them. Okay, so we've set the mode to trunk, non-negotiate. Notice here's our allowed VLANs. We have another VLAN 255, which is our parking lot VLAN that we're not allowing across this trunk link. And here's our native VLAN. And it's the same on both switches. Okay, if I was to look at packet tracer, if I was to look at, I am in packet tracer. If I was to look at spanning tree, I want to show you something here. So I'm going to show spanning tree interface, FA01. Okay, and I'm also going to do FA02. Whoops, I did FA0. There we go. All right, I have them both shown now. Okay, notice on access 1 switch, they're showing both as forwarding. Both links are forwarding. But because we have a loop here, spanning tree is blocking one of the ports. And you can see this amber light right here. It's actually being blocked on access 2 switch. So I want to show you that. And I also want to make mention of this VLAN here, VLAN 255, which is our parking lot VLAN. So let me go here as well. Show spanning tree interface FA01. Okay, it is a root port. That's FA01. We can see by the green link light. And if I do FA02, we can see our blocked port in the alternate role. Now, again, we see VLAN 255 here. That probably shouldn't be shown. So typically, because we configured switch port trunk allowed VLAN, we did not include that in that port in our list. That's if I do, let me do show run here, just to show you this. Yeah, you can see it's not in our list. Okay, so we should not be seeing it here. Now it doesn't show any kind of role or state. So it's but typically if you're on real equipment, and then it can vary between devices. and iOSs, you typically won't see this VLAN 255. If it's not explicitly included in our allowed VLAN list, then it's not going to be included as one of the VLANs being passed. So typically this command here typically only includes VLANs that the interface is actively forwarding or blocking for. And since we didn't allow it on our trunk link, it shouldn't be part of the VLAN information. Now, it doesn't create a real issue here, but we're going to make some adjustments later, okay, to kind of help fix this issue. With Packet Tracer, by the way, great product, great tool. Big shout out to my friend Dennis Frezzo, who is actually the mind behind this, the developer, the father of Packet Tracer, let's say. He used to work at Cisco Systems for many years. So big shout out to him. All right, so let's continue here. And I also want to show interfaces trunk while we're here. Okay, so notice our trunk link includes both ports, although one of them is being blocked. And we do have the right allowed VLANs, but notice it's showing the physical ports here. Okay, we'll see that change when we do EtherChannel. All right, let's go ahead and configure EtherChannel. So I'm going to go here, and excuse me a second, as I'm just going to grab some commands here, and I'm going to put them on both switches, and then I'll come back and I will explain them. So we do a paste there, and config T, and a paste here. We go back up here. Okay, so what we've done here is, first thing is I've done is for our port channel, which is, that's what this is going to be called, when we create this bundle. We're going to do load balancing source destination IP address. That's how it's going to be load balanced across the link. I'll talk more about that in a moment. When we verify all this. Here's the range of ports that I'm going to create for my EtherChannel bundle. Shutdown. This is important, okay? To avoid any kind of inconsistency or synchronization issues, it's important to shut down both interfaces before configuring EtherChannel. And that we won't bring the interface back up until we've done that on both, till one of the, both ends are shut down, and then we'll bring them, and we've configured Etherchannel, and then we'll bring them both up together. Okay, this is where we set the channel protocol LACP. So this is where we're going to do the negotiation. Channel group 1. So this command here assigns the selected interfaces, FA01 and FA02, to channel group number 1, known as port channel 1. We'll see that in a moment. Okay, and yeah, so we'll take a look at that more in a moment. In shutdown, we did the same thing over here. Okay, there's our load balance, same 2 ports. Shutdown, okay, LACP. Okay, port channel 1. Oh, the active. The active means using LACP. Active refers to if both ends are active, then we're going to create a EtherChannel bundle between them. All right, now what I can do is, let me go here. We'll do just the top one so I don't get confused. I'm going to do no shutdown. There we go. Then I'll go down to this switch here, do the same thing, no shutdown. Okay, I'm going to pause here for a moment because it's going to take a moment here for spanning tree to then reconverge and looking at the bundle and all this kind of stuff. In a moment here, you're going to see these lights go amber, and then I'll pause, and when we come back, they'll be green. There we go. Let me go ahead and pause at this point. Okay, so we should see these links coming up here. In a moment, should be all green. But I did a show running config to examine the new running config. I want you to notice something right up here. Okay, a new port channel interface, which is a logical interface on the switch, representing it represents the ether channel itself. Okay, that's been created. Okay, so EtherChannel aggregated the individual physical links, in our case, FA01 and FA02, into a single logical link, which increases the bandwidth and provides that redundancy, as we'll see. Port channel 1, okay, this interface received the commands from the physical interface. That happened when we issued that channel group command. Let me see that up here. Let's see if I scroll up here. Well, yeah, right here. Okay. So we're in this range. When we issued this command here, it created port channel 1. And let me scroll back down here so you can see this. So it received the interfaces from these physical interfaces. Basically, what it did was it inherited, port channel 1 inherited the commands of the physical interfaces, FA01 and FA02. So replicating those commands. You say, well, Rick, I don't see everything. No. Okay. Now, of course, on the physical interfaces is where we did the association. Okay. So we won't see those in the port channel here, but there is one missing. Okay. This is a little packet tracer issue that should be here in the port channel. Okay. And so that's a little packet tracer bug. Matter of fact, if I do this here, show interfaces trunk, we'll come back to this command here in a moment, but let me show it to you right now. Okay. Notice that our trunk link, okay, our trunk link is now port channel 1. Let me actually go down to this switch, show it to you on this one. It's a little less cluttered because there's only one trunk. Show interfaces trunk. Okay. What I want you to notice when I did this command, see this here? That shouldn't be allowed on the trunk. Matter of fact, because it's saying, hey, I'm allowing everything on the trunk. Okay, so packet tracer should have inherited this command. Okay, it did not. So not the end of the world. Packet tracer is a great tool, like I was saying. So all we're going to do is this. Okay, so I'll start here on this bottom switch. Okay, what I'm going to do is go into interface port channel 1. And what I'm going to do, so I don't make a mistake, I'm just going to copy this, and I'll paste it right here. Okay. And I'll do the same thing on this switch here. Paste it. Okay. All right. And we'll verify. Let's need to hit enter. Let's verify that everything looks a little better. Let me do show run here. And yes, we can now see. Okay, it has the allowed VLAN. Okay, has the correct switch port trunk allowed VLAN command there. Let's do this here. Show interfaces trunk. And now, yes, see now our port channel, this is the one that has another trunk link here, gig01. But now our port channel trunk, yeah, so it's no longer including 255. All right, we're going to talk about that command here more in a moment here. Actually, let's talk about it right now. Let me go down here, do the same command. Let's do show interfaces trunk. All right, that's a little easier one to look at. Okay, so the port channel that we create is actually abbreviated PO1. Okay, it represents the logical ether channel link aggregating the two physical interfaces, FA01 and FA02. So this is what we're going to see as far as our trunk link. So the trunk port with the specific VLANs and native VLAN that we configured initially for the fast Ethernet ports, FA01 and FA02, are applied to the port channel. Okay. Now, another thing to mention, this is important as well. Any configuration commands we make now, let's take a look up here. Any configuration commands we make, show run, so we can see the correct output. There we go. Any changes we make to this trunk link, we would actually now make them to the port channel interface, not the physical interfaces. Okay, or we can have, again, some inconsistencies or synchronization issues. So let's say we're going to change the native VLAN. We would not change it down here. We would change it here. Okay, and then it would be replicated in the physical interfaces. All right, let's take a look at a few things here. Notice we have a green link light here. That's good news. So let's go down here and take a look at spanning tree. Show spanning tree. Interface FA01. Okay, that FA01 port was forwarding before, green link light, but remember it was amber before there. So let's do FA02, and we can see that is also forwarding now. Okay, so we can actually verify it over here too. Both ports are forwarding. Just having a little trouble spelling spanning tree. Okay, interface FA01 forwarding, and let's do FA02. Okay. And I can do one more, actually. I could actually even do port channel 1. Okay, yes. So it combines the two. They're both designated ports, and they're both forwarding over here. Okay, they're both combined. The Ether channel bundle is a root port, and it is forwarding. Pretty cool stuff, huh? All right. All right, let's continue looking at a couple more things here. What else do I want to say? Oh, yeah, we need to verify Ether channel, don't we? So I'll just go up to this switch here. Let's just do show Ether channel. If I do question mark, we can see that we have a few options here. Let's take a look at these. If I hit show Ether channel all by itself, it tells me that we're doing layer 2 Ether channel. We have 2 ports in the bundle. We could have a maximum of 16 in this bundle. We have 1 port channel and a negotiated LACP. All right, what else we want to look at? Oh, one of my favorites. Summary. This is cool stuff. Show Ether channel summary. Okay, some similar information here, number of channels and group things, but this one, group 1, that's port channel 1, SU. Okay, so what is that S? Okay, make sure you find the uppercase S, not the lowercase s. Lowercase s is suspended. Uppercase S means layer 2 Ether channel. U means it's in use, it's active. LACP is the negotiation protocol. Here's our 2 physical ports. P means it is a port in that channel. All right, another one that I want to show you that actually can give some really good information. We do port channel. Now, this could be really good if we had some live equipment here. I'm not going to go through a lot of it, provide some load balancing information and other things, but just the basics here. Port channel 1, negotiation protocol. Here's our ports. They're both active. Okay, number of ports too. Okay, but there'll be more information there if we were passing some traffic and we're on probably real equipment. All right, one last one. Just do show Ether channel load balance. Okay, so we did the command source destination IP address. Okay, which means that it's going to load balance on source and destination IP addresses for IP traffic, IPv4 and IPv6. And if for non-IP traffic, things that do not have an IP header, like ARP, for example, it will use the source and destination MAC address. It doesn't exclusive OR. I won't get into this, but it is not a equal cost load balancing type of algorithm. It actually does a hash based on the number of links and the lower order bit. I won't get into that, or bits. So I won't get into that here. You can, Google or whatever, look up the load balancing algorithm for Ether channel. It's actually quite interesting. But the one thing you want to be careful of, you do want to, it usually will be fine to go with source destination IP address. The only time that might be an issue is if you have a bunch of clients here and a single server at the other end. Then it will probably overutilize half the links. In our case, one link out of two. Okay, but let's get past that. And I think we're pretty good with, we're done with layer 2 ether channel. Okay, and we'd replicate that. If you're doing my lab, you want to replicate that on all these switches as well. Let's move ahead and do layer 3 ether channel. Okay, so that's right up here. We're going to do routed ports between two layer 3 switches. Commands are identical pretty much for routers. Okay, so let me pause the screen here so get kind of set up here. Okay, I didn't want to waste your time by logging in and everything, but I just did a show running config on both layer 3 distribution switches. If you remember, when we did the routed port, we configured those as routed ports. The no switch port command does that, turns into a layer 3 physical port. Here's the IP address on one end, gig 10/24, and similar on the other end, 1024, no switch port, layer 3, and there's our IP address. Okay, so what we're going to do is let's actually look at a few more things before we create that link. Just show IP interface brief. You know, everybody's favorite command here. I can actually remember when I first realized that command. Actually, it was shows you how old Rick is. It was a new command when I was first doing this. Okay, there's the physical interface. Okay, so gig 10, just like a router. Physical interface IP address. Okay, let's do show IP route. You're lucky not in my class. I always tell old war stories like this. Okay, show IP route. We have it shows right here that gig 10/24 is directly connected to this network. And it shows similar on the other layer 3 switch as well. So what I'm going to do now is I am going to add, we're going to make this 1023. And it shows up as the bottom link. There. So that's that one there. So now what we are going to do, and I'm going to do, is configure layer 3 ether channel. So let's do that. Kind of do that step by step here, config T. So the first thing that I'm going to do is I'm going to go into the physical, copy and pasting here. Okay, going to go into gig 1024 where we had the IP address configured, no IP address. All right, you might have noticed I made a little mistake there. That's why I paused the recording. I saw it. And anyway, let me go through this again. I mentioned we want to create a different port channel. So I did the right thing here, interface gigabit 10/24, remove the IP address. This is where I made the mistake. And this is where we learn, right? You never learn when, you learn a lot more when things go wrong than when they go right all the time. So interface port channel 2, I said I wanted to create a different port channel for this. Port channel 2, not 1. So no switch port, IP address, no shutdown. Then here's our physical ports here. Gig 1023-24, again, layer 3, no, layer 3 port, not layer 2, just like we did here. Layer 3 port, not layer 2. Negotiation protocol, LACP. And this is channel group 2, has to match this. Okay, so I'm glad I made the mistake because that way we get to see this. And active means both ends are active, active for LACP. It'll create the port channel. Okay, the ether channel. Okay, so this needs to match this. Okay, all right. And I did the same thing over here. I made the same mistake. I was copying from something here, which the beauty of automation is it can make your configurations go very quickly, but also when you make a mistake, you can make it very quickly and push them out everywhere. I'll be doing other things. I'll talk more about automation, like with Python and Miko and Napalm and Norner, other videos. All right. Interface. There's our one physical interface, no IP address. Okay. I'll remove that. Here's our port channel 2, layer 3. We made it. There's the IP address now. Okay. No shutdown. Here's our range of physical ports. Again, layer 3, LACP, channel group 2, or channel 2, mode active, LACP. So now we should be good to go. Okay. Let's take a look at a few things here. How about if we do, I want to do some show IP interface brief and some good stuff there. So let's do that. Okay, we could do show run here. We'll see, just so you can always see what you did here. There's port channel 2. And we go down here to gig 0, 23, and 24. Okay, let's see that configuration there. Let's do show IP interface brief. Okay, we can see our port channel now has the IP address up and up. And if we go down here and look at our physical ports, they're up and up, but they're unassigned as far as the IP address. It's up here. Okay, that's pretty cool. How about show IP route? So our directly connected network was gigabit 1024 before. Now it's assigned to the port channel, which is representing physical interfaces physical interfaces gig 23 and 1023 and gig 1024. I think I said it was FA whatever. This is what it used to be. Okay, gig 1024. Now it's port channel 2 that's representing actually both of these ports. Okay. All right. I think we're just about there, believe it or not. Let's do a couple of quick show EtherChannel commands just to see the differences. Okay. Notice it says, here's our show EtherChannel, layer 3. Okay. Group 2. Okay, because we did port channel 2. Let's do show EtherChannel summary. Okay, so looking at this command. All right, here we are, group 2, port channel 2. Okay, this is what's different. It's layer 3, not layer 2, the S. Okay, LACP. There's our 2 gig ports. Okay, they're port in channels. What else should we look at here? Anything else we really need to look at? I don't think so. I think, oh yeah, there is one more thing I think we need to look at. We need to make sure all this works. Don't go home until you make sure it all works. All right, so let's go here. Desktop, IP config. Actually, I'm actually going to go down here. You see that actually, we do IP config. All right, hide all that stuff, some stuff I was doing before. Okay, there's its IP address, default gateway, distribution 1 switch. So this is going to, if this works, we're going to go from here to here. Okay, so we're testing our ether channel here, our ether channel here. Now, I did not configure ether channel here or here. You're going to do that if you're in my class. Okay, and if you're not, do it anyway. We're gonna make this a really cool network here. So let's go ahead and ping 1034.101. Okay, and by the way, normally if this is the first time, there'd probably be a timeout or two because of the ARP requests, but not in this case because I had already tested it during the pause. All right, anything else? I think we're good. Just remember, any configuration changes you make now to like change the native VLAN here or any kind of changes here, like routing changes, you're making them to the port channels, not to the physical links. Okay, great. I hope you enjoyed this. We're going to be doing even more stuff. We're just about there with the actual network plumbing. And then we'll be doing some cool stuff with DHCP, relay, and security, and a few other things. A little bit more on spanning tree, first hop redundancy protocols and stuff coming up as well. Have a great rest of your day. Thanks.